Hi guys, you're welcome to my channel. Today we are going to be looking at Mechanics Practical Neco 2021. And this experiment, if you look at it, like we have the question on the board, the experiment is to test the simple harmonic motion of a spring mass system. Now when we talk about a spring mass system, we are talking about a spring that has a mass attached to it. And whenever you attach a mass to a string, either vertically or horizontally, what will happen is that the string is said to oscillate. Now, examiners have no time to go to the lab to carry out the experiments after you've done it. But they have some certain things that they always use to cross-check if your reading is actually right or wrong. Aside from the fact that they know how the graph should look. That's number one. Number two, they also have some parameters in the questions that they can easily use to test mathematically if the reading you get is actually correct. Although they are going to give you room of error of 0.5 plus or minus 0.5 error. So when you commit such error, they overlook it. They know that they are regarded as experimental error. So I'm going to take you through how an examiner is going to cross-check your work and how you yourself can cross-check your work if you are right or wrong. Although some teacher tag it as a way of manipulating reading, but I'm not teaching you how to manipulate reading here, and if it is, you take it like that. Okay? Now, let's look at something now. I'll first of all let you understand that experiment on simple harmonic motion is mostly used to determine acceleration due to gravity of a place. And when you want to determine acceleration due to gravity of a place, you need to look at the relationship between the period and the frequency. Therefore, look up, if I have this equation that t is equal to 2 pi the square root of m divided by k, where k is my spring constant and m is the mass that I will be attaching to the string, and t is the period of oscillation. Now, if you observe something, you will see that on my table here, this is how Neco gives us the table. In some cases, they will give you a table like this, and in some cases, you will not be given a table. Whichever one, you should be able to go on with your experiment. And if you still find it difficult to get your table from the given question, you can check my previous videos on experiments in physics. And also, if you are finding it difficult to plot graph, you can also check my videos on how to plot graph. Then you can ask whatever question you need to ask in the comment section. Okay guys, look up now. The examiner asks us to produce L0, which is the initial length of the string before we attach the mass to it. What do they want to use this for? What the examiner wants to use this for is to be able to determine what is your extension when you apply the certain amount of mass. And by the time they know your words, they know the mass you apply, and they know the extension caused by that particular mass. Are we together now? If they know the mass you applied, and they know the extension caused by that particular mass, they can easily tell what the spring constant of that particular string will be. And when they know the spring constant, as they are changing the mass, they can determine what the extension will be. That is case 1. Case 2, as you are increasing the mass, they can easily determine what will happen to the period since the spring constant is known. And that is why I have given this equation. By the time you know your spring constant, if I have a mass of 50 grams, I can tell you what the period will be. By the time I know your spring constant, if I increase the mass to 70, I can tell you what the period will be. Are you getting this now? Therefore, I would like you to note something in your experiment. Once your mass is increasing, what happens? Your period will also be increasing. Because if you look at this now, if I square both sides of this equation, I'll be having t squared to equal 4 pi square m divided by k. For me to check the relationship between what? M and t square, I can make 4 pi square divided by k to be 1. And if I make that to be 1, or I make it to be a constant, so you will see that t square is proportional to what? To m. Whenever you increase the mass, t square will increase. And anything that makes t square to increase, it means the period as what? Increase. Anything that makes the period to increase, it means the time to complete the number of oscillation has also increased. Since period is given as the time to complete the number of oscillation divided by the number of oscillation. I'm writing 20 because the question says we should count 20 oscillation. So let me just generalize, because Neco can decide to change the question and say 30 oscillation or 50 oscillation or 10 oscillation. But whichever one, just know that your period is t divided by the number of oscillation. Now let's go into the experiments now. If you look at the diagram, this is how our experiment setup should look like. Here we have our meter row, we have a retort stand, and we have our split cork. Then we have the string, we have the pan, then we have the pointer. Those are the things that we are going to arrange now in order to look like this. Are we together? Now, this is my meter rule now. You can call it ruler, anyone. I'm going to what? Put it in this particular cork split. Then I'm going to screw until it's balanced horizontally like this. Okay, so you can see now it's vertically firm. So the next thing I will do now is to attach what? My spring to the same retort stand. So I'm doing the same thing here now. So make sure you attach it such that it's not going to pull when you apply mass to it. Now, actually, I don't have a pointer in this lab, so I intend to improvise by using my optical pin as my pointer. So this is my pointer now, the optical pin, and here is the pan that I will be using to slot the masses. Now, listen, your school might provide you with a pan that is 50 gram. If it is a 50 gram, what you just need to do is that subsequent mass that you are going to be putting, add that 50 to it to equivalent what is requested from you. For instance, if they say a mass of 70 gram, and you know that your pan is weighing 50 gram, all you need to add is just what? 20. So that it will be 20 plus 50, that will be 70. Or, better still, I will advise that you should use a light pan like that of 20 gram weight. The pan using what? To slot in 20 gram weight, that the mass is negligible. You can just neglect the mass, like the one I'm holding like this. So consider the mass negligible. So I attach it to the spring, and I have this. So I'm done with my setup now. So the next thing is to go through what? My question, and see the way I'm going to do what? Going about it. But before I go into that, I would like to know what the initial length, or before then, let's just go to the question. You get to know it better. The question says, suspend the spiral spring vertically as shown in the diagram above. That is what we just finished doing now. Then the second question says, attach a scale pan and record the position L0 of the pointer of the meter rule. So now that I attached what? The mass, I have to know what the position of this string would be on this meter rule. That will be my initial length, the natural length of the string. Are we together now? The natural length of the string. Okay, let's quickly see that. Now, if you look at my string, this my meter rule is starting from 46. So I'm taking my 46 to be my 0 point. Are we together now? You know, this is the 0 point of the meter rule which I'm supposed to start from. But because I inclined it at this point, so I'm starting at where? 46. So 46 is what? 0. Now see, my pointer is pointing at 78. If you look at it here now, my pointer is approximately pointing at 78.5 rather. Now that the pointer is pointing at 78.5, what will be the length of this string? To get the length of that string, what I will just do is that I'll say 78.5 minus 46.0. Are you getting this now? So if that should be the case, this will give me 5 minus 0, that will be 5. 8 minus 6, that will be 2. Then 7 minus 4, that will be 3. So I'm having 32.5. So that 32.5 is going to be the length of my spring. So what's the next thing? I already recorded what they asked me to record. Now, question 3 now states that had a mass M equals 70 grams to the scale and record in the table the new position L of the pointer. Deduce the extension E equal what? L minus L naught. And equal L minus L naught produced. So now let's quickly do that now. I'm going to add a mass of 70 grams to this pan. Now this is a mass of 20 grams and this is a mass of 50 grams. So 20 plus 50 will give me 70. So I'll do that now. So I had a mass of 50, then I had a mass of 20, making 70. Remember I said you should neglect the weight of the pan. So after putting that, what you observe is that the spring pulls down. So now let's check what the new length will be. So if you look at the new length now, this is on, please don't pull this string, don't pull it. So this is on 79. So if my new length is 79, what is going to be? 79, remember that I'm starting from what? I'm starting from 46. So I'll say 79 minus 46. So 79 minus 46 is going to give me 33. So I'll record it as 33.0. Are we together now? Okay, so I'll go to the next question. What's the next question there? Because I'm to determine the extension now, isn't it? So, for me to get the extension, I'll say 33 minus 32.5, and that will give me 0.50. Do you understand this now? Good. So, what's the next thing? We've done with the Roman figure 3. Roman figure 4 says, set the suspended mass into vertical oscillations of small amplitude. Measure and record the time t for 20 complete oscillation. Then record the result in the table. Calculate the period t of the oscillation and evaluate t square. So we have a lot of things to do there now. Okay, if that should be the case, let's quickly suspend this to vertical oscillation. Here is my stopwatch that I will be using. If you are using this kind of stopwatch in your laboratory, so what you need to do is that when you want to start rotating it, you take this down and you see that it started ticking. When you want to stop it, you press this. So you can see, when you want to stop it, I'm coming, let me reset it, sorry. If you want to start it, you take this down. You can see it started ticking. When you want to stop it, you take it up. You can see that it stopped. Then when you want to reset it, you press this. Then it resets. That's how to use this kind of stopwatch. Now watch. the way I'm going to count. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I'm going to retake this for some reason, and just look at what I'm going to do now. Please, I'll restart my stopwatch now. And watch. I'm going to suspend it into what? A very small amplitude now. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'll record my time. If you check my time now, this is going to be 15, and if you look at it, 16, 17, 18. So this is 18 seconds. So I record down the time for the 20 oscillation to be 18.00, because the time is already in seconds, so there's no need of you putting units in your box because the unit is already above it. So 18 seconds. How can I get my period? To get my period, I'm going to say the time for 20 oscillation divided by what? 20. And that will give me my period. So let me quickly use my phone to get that. So I have the 18 divided by 20, and that gives me 0.9. So I'll write down 0.900 because I'm using calculator, so I have to leave it in 3 decimal places. Okay, so I'll look for what? T square, which is the next thing to evaluate. T square. So that will give me 0.810. So that was 0.810. So I'm done with the first one, the first reading, which is that of 70 grams. So I'm going for that of 90 grams now. So for me to make it 90 grams, I will just add 20 to that of 70 that was there before, and that makes it what? That makes it 90. So I'll check what the new length will be now. And what's the new length? The new length now is right on 79.5. So don't drag this, please. So we have 79.5, 79.5. So, and for me now to get my result, I'll just say 79.5 minus 46.0. This will give us 5 points. This will give us 9, that's 3. So we have 33.5. So this will be 33.5. I will send this now. So what will be the extension? The extension is going to be 33.5 minus 32.5, and that is 1.00. So the next thing is to determine the time for what? 20 oscillation. So I'll first of all reset my time back to normal. So and now what? I'll suspend it now. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so like I do earlier, I would still like to take the reading again and see what my result will be. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so my time now is on 25 seconds. So the time is 25.00 seconds. So what will be our period? That will be 25 divided by 20. 25 divided by 20. So that will give us 1.25. So I record as 1.250. And what will be the period? So I'll just square what I have. That is the square of the period square rather. That is the square of 1.25. And that will give us 1.563. 1.563. Okay, so we'll move to the next one, which is 110. So when it is 110, I will just apply another 20 to make it 110. Then I'm going to check what the new extension, that is the length, will be. So what will be the length? So if you check now, the length is on 80. Without stretching the string, I have this to be on 80. So 80 minus 46, that will give us 34. So I have 34.0. What will be my extension? So that will be 34 minus 32.5. That will give us 1.50. So what will be the period of 20 oscillation? So let's quickly check that now. But before then, I will restart my stopwatch. Okay, so 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so as usual, I'll take the time again. Normally, what I'm supposed to do, other than what I'm doing now, is that I'm supposed to be taking the time twice. Then I'm going to take the average of the time. That's what I advise you to do. I'm only trying to save my time here. Cool. Okay, so let's go again. And this will be the last time that we're going to repeat it twice. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so we have the time to be on 39. So 39.00. So our period of oscillation now will be 39 divided by what? 20. 39 divided by 20. So we have 1.95. 1.950. Okay, so square of our result. Okay, the square of our result, that will give us 3.8025. Okay, 3.8025. Okay, that's 3.803. So 3 decimal place. Okay, so we move on to 130. So 130, we suspend our mass there. So this 130 now. So the next thing is to check the new length now. Okay, the new length now is going to be what? 80.5. So that will be 34.5. 34.5. So our extension is going to be what? 2.00. So what will be the time for 20 oscillation of this now? So we set our time. So we have this now. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so this is quite on 33.5. Okay, sorry, this 32.5. Sorry, there's a mistake here. 32.50. This is 29, not 39. Okay, sorry, it's 29, not 39. That's my eye error or marker error. So it's 29, sorry. 29, and you cannot even tell me. I think you can hear me. Okay, sorry. You're going to comment. So it's 29 divided by 20. So that's 1.45. 1.450. So we'll square our result. What are we going to have? So that's 2.103. Okay, and the next one is 32.5 divided by 20. So we have 1.625. So we'll square our result. What are we going to have? Okay, that's 2.641. Okay, so move to the last one. That's, we had another 20 to it, making 150 bar. Okay, so what will be our new length now? So absolutely our new length is 81. So that will make that to be 35.0. 35.0. So the extension is going to be 2.50. And what will be the time for the oscillation? So we reset this now. When we reset that, we count 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what we check here now, we have 33.5. 33.5. 33.50. Okay, our period of oscillation is said to be what? 33.5 divided by 20. So we have 1.675. 1.675. Then we square our results. What are we going to have? We have 2.806. Okay, so that's about that. We are done with our table completely now. So what's the next question? After getting the table done completely, the question says plot a graph of E on the vertical axis against T square on the horizontal axis, starting both axes from the origin 0, 0, and determine your slope. Okay guys, let's verify if our experiment is actually right or wrong. If you look at the equation here, you see that when T square increase, the mass increase. So if you look at this also, When t square increase, our what? Our mass is also increasing. So kindly check. If it is not like that, then there is problem in your oscillation. Now, let's say you now want to manipulate, which I'm going to cover in another video. So let's go by plotting the graph now. So plot the graph now. So we are going to be now looking into how to plot the graph now. So we have to plot the graph of extension against t square. So that is extension on the vertical axis and t square on the horizontal axis. So remember, the rules of graph is that it must cover 2/3 of your graph paper. That is, if you divide this graph paper into 3, your graph must cover 2 out of that 3 divisions. That's what it means. And if you are still, if there's any other information you want to get about graph plotting, you can check the description box below to find the links to the video on how to plot graph, and I think it's going to do you well. Cool. So extension, the maximum value there is 2.50 and the minimum is 0.5. So let me count 1, 2, 3 first and place my ruler there. So if I do that now, I'm going to okay, by the time I divide this thing into what? Into 3, at least this is going to be the one portion and this 2 portion is going to be where my graph must cover. Are you getting this now? That's the idea, guys. Okay, so let me now choose a unit of 0.1 and see if it's going to occupy 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. It's not even up to 1. Okay, let's increase this to 0.2, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8. It's not even up to 2. Okay, we have no choice than to increase this to 0.5, 0.5, 1, 1.5, 2, 2.5, then 3. Okay, so we have about 1, 2, 3. So let's shift this ruler upward so that we can have a reasonable space above it. So, okay, so we rule our horizontal line like this. So you can decide to take it back if you actually want it to be more deeper. Mind you, there is no rule that states that you should use pencil or biro in plotting graph. Anyone you use, you're good to go. But as a student that are used to master plotting of graph, it's advisable that you use what? Pencil. So let's move on now. The first thing you have to do under your table is to write the title of your graph. Title of graph. So we have that the graph of E against t square. So scale of the graph now, we have 2 centimeters because from this box to this box is 2 centimeters. Although sometimes Neco can give you non-standard graph that the space between one box to the other is going to be 0.1. Sorry, it's going to be 1 centimeter rather instead of 2 centimeters. So you have to check. This box now, you measure it. This one is what? Is 2. You can see. But Neco at times give what? 1 centimeter box. So if it is 1 centimeter box, you write 1 centimeter represents whatever unit that you have. So here now, 2 centimeter represents 0.5 units on vertical axis. Vertical axis. Remember, in physics, there's nothing like y-axis or x-axis. That is in mathematics, because in mathematics we deal with coordinates. So, and when you talk about coordinates, x-coordinate, y-coordinate, and z-coordinate. But it's not like that in physics. Is that you say vertical axis or horizontal axis? Or, preferably, you say 2 centimeters represent 0.1 unit on E-axis. That is extension axis. Is that taken now? Okay, you can watch the video on graph to learn more about what I'm trying to say here. Cool. So we now determine the scale of the horizontal now. So you can't just 1, 2. For the horizontal, place your ruler there. Then you have to check what's the maximum value here, 2.8. The minimum is 0.8. Okay, if I choose 0.2 as my scale here, is it going to occupy this space? 1, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6. It's not sufficient. Let me increase it now. If I increase the value of this to 0.5, for instance, 0.5, 1, 1.5, 2, 2.5, then 3. I think this is okay. Abi? So I can rule my horizontal line here. Can return it also. So I have that 2 centimeter. Please don't abbreviate. 2 centimeter represents 0.5 units on horizontal axis. Or you say on T-square axis, anyone. And I can decide to rewrite this my scale. Since I have the same units for both axes, I can say 2 centimeter represents 0.5 units on both axes, that is vertical and horizontal, or E and T-square. Okay guys, so like I used to tell you, and people used to question me that what do I mean by it? Graph is a vector quantity. Okay, your graph is a vector quantity, and what makes a graph a vector quantity is that a vector quantity is a quantity that has a magnitude and direction. Your graph, whenever you have a negative value, either on vertical axis or horizontal axis, you know where it's going to point to. So it has a direction for positive, it has a direction for what? Negative. And that's what makes it a vector. I think I answered your question today. Okay guys, okay? So this is the 0, 0 origin. So let's label. This is going to be 0.5. This is going to be 1.0. This is going to be 2.0. This will be 2.5. And this will be 3.0. And this will be 3.5. Okay, so here now I have 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, and 3.5. Okay, when E is 0.5, our T square is 0.81, right? Okay, remember, each of these small line, they are equivalent to 0.05. Are we together now? Okay, so you must have seen that in our previous video. So let's go on now. This is our E in centimeter, and this is our T square in X square, in second square rather. So when this one is 0.5, this one is 0.81. So if this is 5, 1, 2, that will be 6, 1, 2, that will be 7, 1, 2, that will be 8. Abi? So this is 0.8 now. So 0.81. That's what we have, right? So it's going to fall in between there. Okay? Okay, so what next now, guys? What next is to trace this to 0.5. So this is 0.5 here. Are you seeing this now? Cool. So the next one is when this one is 1.56, the other one is 1. 1.56 is going to be 1, 2. This is just 1.56 down to what? 1. So this is 1. Okay, so the next one is when it is 2.1, this is 1.5, so 2.1, so let me also that, going to be 2, okay, so 2.1, this, so 2.1 down to what? 1.5, so this is 1.5 here. You can see I'm not doing dot line to those points. You can see I'm using my ruler as a guide. That's what you should do also. Okay? 2.6. So this 2.5. So 2.6 is going to be here. Okay, forget about the one at the back. I'm just considering the first 2 decimal place. Okay, okay, so down to what? To 2. So this is 2. Oh, that's a mistake. Oh, I think there's a mistake somewhere here. Okay, 0.51. Oh, 1.5. Okay, I think it's where I'm labeling, so I have to correct this. Okay, so this is supposed to be our 2. So I'll correct that here, and that's why you should use pencil, because of such mistake. Okay, so 2.8 now to 2.5, 2.8. So I'll count 1, 2, this is 6, 1, 2, this is 7, 1, 2, this is 8, down to what? 2.5. Okay, so this is 2.5 here. All right, okay. So let me label this. So this is supposed to be 1.5, not 2. And this is supposed to be 2.0. This is supposed to be 2.5, and this is supposed to be 3.0. Okay, I think I've corrected that. Okay, so I place my ruler at the origin to see if it's going to pick something. No, it doesn't, because at least it must pick 3. Okay, so if I try to pick this now, it only picked 2 here. Okay, what about this? I think it picked 3 now. Okay, so it's picked 3. So if I rule down like this now, okay, so I have this, okay. So I can take this down like this. Taking my slope now, so I will not talk much about all these aspects. So if you actually want to know more about it, check my video on graph plotting. It's a free video. Okay, so this is E2 and this is E1. So here will be okay, t square 1, and this will be t square 2. All right, so this is change in vertical axis. Okay, I just like doing this, although I'm not doing it this time around. The biro I'm using, it's not a good biro like that. Okay, so this is the change in t square, and this is the change in what? E. So we're done with the graph, and that's all about the experiment. So do well by practicing very well before your exam. Have a nice day.